Good morning, ladies and gentlemen. A very warm welcome to today's session brought to you by etenergyworld.com. Wet stacks have gained popularity worldwide as the use of flue gas desulphurisation, or as we commonly call it, the FGD system, has increased, and many owners have decided not to reheat the water saturated flue gas emitted by the wet FGD system. In fact, many coal fired power stations are moving to highly efficient FGD wet stack operation. But do power companies realize the potential risk of this technology? How can the operating conditions be characterized, and how should an owner make sure that his contractor uses a suitable design based on materials that will be durable as well as reliable at the same time? In fact, what are the environmental risks of FGD wet stack operation, and how can these be controlled? To find answer to some such pertinent questions, we have with us today an extremely experienced industry veteran who shall walk us through a topical matter. Allow me to welcome Mr. Albert D. Kreij, Managing Director of Hadek Systems. Albert has been with Hadek since 1990 and has worked directly with customers in Europe, North America, Southeast Asia, South Africa, as well as the Middle East. And talking about Hadek, it is a well-known supplier of internal lining systems for power station chimneys. Over the past 20 to 30 years, Hadek has supplied its technologies to power stations across the world and has specialized in protecting chimneys that are operated at low temperatures. With that, a sincere welcome, Mr. Albert.
Thank you.
So, without any further delay, I'll put forward my first question to you today. So, my first question goes out that what are the ways in which power companies can ensure quality delivery from EPC firms in terms of overall equipment and technology when the lowest cost model promotes contractors to cut costs to the bottom? What would be your view on that?
Well, that is a very big question. It is much bigger than just the area where we work, which is chimneys. Generally speaking, I do believe that power companies must be highly vigilant in selecting suppliers and sub-suppliers for their projects. There is a lot of money at stake, and the proper operation of these power plants over a period of 30 years is very important. When I look at the area of chimney linings, there are several technologies that can be used that are all proven and all good. I'd like to mention special metal solutions known as high nickel alloys. I, of course, have to mention special plastic solutions known as FRP. And then, of course, there is the area where our company is very active, which is borosilicate glass block linings. I am only qualified, I believe, to comment on borosilicate glass block linings. And I must say, unfortunately, when it comes to the selection of vendors in this specific field by power companies in India, I am seeing that many of these companies are not highly vigilant. To illustrate, we have seen that some vendors have been accepted based quite simply on providing some documents that confirm that they have a good product which has been used successfully in some power plant in some faraway land. And invariably, these certificates will come with some stamps and some signatures, but it is very hard to check the reality behind these certificates. In my view, the only way in which a power company can truly select a vendor as an accepted vendor as being sufficiently qualified is to go with their own engineers to the power plants that use the product, to talk to the people directly, and if in any way possible, to go into the chimneys that are lined with the product and see it for themselves. Otherwise, the risk of misinformation is huge. And I do know, as you had mentioned in your introduction, power companies all over the world have used our lining technology. And I do know that the first customers in India who use our technology have come to reference plants by themselves, and they have been highly strict in assessing and evaluating our technology. And I would recommend to do that for any potential supplier. I have to say, unfortunately, now in India, there's even one supplier who is supplying his product who doesn't even have any experience in FGD wet stacks, which is the specific case that we see mostly in India. And so based on that, I do think there is a lack of vigilance. On top of material quality itself, I also believe, and our company believes, that the material itself, while it is essential, is only half of the total picture. The total picture has to include also the installation of the lining system, because even if you take a very good material and it's badly installed, the actual result in the field will still be bad. So we recommend that the lining installation must be supervised by representatives of the lining supplier full-time. And furthermore, we recommend that any guarantee should be a single source guarantee. And by that I mean that the guarantee should be for the material and the installation, and it should be in the hands of one single party, because to have the guarantee divided over two parties is a recipe for disaster. It has to be a single source guarantee in the hand of one party. So this was a lengthy response to a very straightforward question. I'm sorry for that, but this represents our point of view.
Actually, quite a concerning situation. The point that you have already mentioned about the Indian market. So, moving on, can you explain the criticality of the FGD wet stack chimneys from the point of power plant operations and the need to cut emissions at a time, when the environmental movement is perhaps at its peak?
Yes. Of course, when power companies invest in a flue gas desulphurisation system, their main focus is on the FGD absorber and all of the moving parts that it has. And no doubt, these aspects are very important and they have to be chosen very carefully. The chimney, however, it should also be considered as an element of key importance, because if a chimney is built and internally protected in an insufficient manner, the lining system will fail, the chimney as such will fail, and it will become a huge cost, and it will also affect the availability of the power unit. So very clearly, we believe that the chimney and the chimney flue lining and the chimney lining should be very much part of the picture, as it will be an element of vital importance for safe power plant operation.
So this leads me to my next question, that is, as we all know that India is yet to adopt the global best practices when it comes to managing safe operations of chimneys. So according to you, what does a country like India need to do to quickly capture the lost ground in terms of time as well as latest technology on this particular aspect?
You have to ask, what does it mean best practices? Of course, best practices at a minimum means selecting proven safe technologies and proven capable suppliers. But actually, I believe that in India right now, the number of projects that has to be built is huge, and the finance available for realizing these projects is quite constrained. So in the case of India, I would say best practices also means taking the concepts that represent the best economical solution with the lowest long-term costs. Our company believes that in FGD chimneys, it is no longer necessary to use internal flues, and these chimneys can be very strongly simplified by using a concept that we call the new chimney design. So what is the new chimney design? It is a concrete shell that does not contain any internal steel flue, and as a result, the concrete shell can be slender. And the lining, the borosilicate glass block lining system, is applied directly to the inside of the concrete shell. By building a chimney in this way, the construction cost can be very strongly reduced by more than 30%. And also the construction time can be reduced by about 5 months or more. And additionally, and this can be important to quite a few power stations as well, the footprint of the chimney is strongly reduced. It requires much less space. So we would recommend that in the case of Indian power companies, best practices very much includes considering this new chimney design. It is not new, even though the name does suggest that. It has been used for almost more than 15 years now, and it has been proven to be very safe, very reliable, even in FGD wet stack operation, which is the very onerous type of operation that is considered by most Indian power companies. So just to quickly summarize what I've said, best practices for India means to be vigilant about the quality of suppliers, but also very much to look at this special chimney design that reduces cost and construction period and footprint.
This leads me to my last question, that is, at a time when power companies are facing so much pressure to run the FGD wet stacks at high velocities, how can companies use design related and other kind of modifications to manage and address this kind of issue? What would be your take on that?
Well, first of all, I'd like to confirm that this is really a big problem. And this is not only for power plants in India, this is for many power plants worldwide. When they have to build a chimney in conjunction with a flue gas cleaning plant, they have to dimension the chimney based on some values, some assumed flue gas volumes. And invariably, the type of data that is used for that is expected flue gas volume during a normal full load operation. Unfortunately, in many cases, that is not enough. As you say, the power stations in India and in other countries around the world are asked to produce at maximum capacity, and they will frequently be operating at their so-called design point. And moreover, they will sometimes be firing coal of lesser quality. And what we have seen in quite a few power stations is that the flue gas volumes can go far beyond the flue gas volumes that were first initially assumed. So this is a big problem for chimneys because, as you may know, in FGD wet stacks, the flue gas velocity has to be limited very strictly to normally a value of 18.3 meters per second. That is the normal accepted velocity for FGD wet stacks, where the condensate on the walls will still be flowing downward and can be safely drained at the bottom of the chimney. If we go above 18.3 meters per second with a normally lined chimney, we will see that the chimney will start spitting acid droplets onto the power plant itself and into the environment surrounding the power plant, which is called spitting, and it's a huge problem. So if we go back a second to this problem where power plants are operating far beyond the assumed design data at design capacity, or even a little bit beyond in the case of low quality coal, the problem is that the chimneys will be operating at more than 18.3 meters per second, and this spitting problem can happen. So we have developed a solution for that, which is to use the lining in a very specific way, where these individual blocks are not placed in the upright manner, but where they are placed under an angle. We call this the 45-degree high velocity pattern. By using the lining system in that specific pattern, the limit for operation is shifted from 18.3 meters per second to well above 22 meters per second, almost 23 meters per second. So even when chimneys are at a later stage operated at higher velocities, the chimney can still be safe by implementing this this modification in the lining system. I can add to that the first power plant in India that is going to operate for sure at velocities higher than 18.3 meter per second will soon install this lining system. So in this sense, India has the world premiere of this new technology. And we believe that there are quite a few other customers in India and outside of India that can benefit from this technology as well.
Thank you, Albert. Well, that leads us to some really insightful takeaways. So, my first observation is that, chimney reliability is key to overall power station reliability, and as such, unit availability is directly at risk from the use of non-qualified lining products. And mention not using the right design and materials is of key importance here. Secondly, one major takeaway that came up from today's discussion is how crucial it is to install borosilicate glass block linings under the supervision of an experienced organization, because the job doesn't really end by selling the product. In fact, the real work starts after that. In fact, if the correct set of guidelines and protocols are not abided by, it will cost very dearly to the chimneys and definitely the environment which we all are trying to protect so very dearly. And this leads to a very critical element, that is awareness, because awareness of technical know-how, the aftermath of using products basis their price only, will definitely incur a huge loss for the power plants in the long run. And lastly, performance certificates from renowned and most importantly, reliable manufacturers and suppliers is definitely the need of the hour, by which environmental hazards can be curbed alongside leading to increased performance by power plants at a very top capacity. So any further points that you would like to add onto this?
Well, I would like to first of all say that you have summarized it perfectly. I could add maybe the following. We have customers in other countries who have made the wrong choice with the chimney lining. I will not mention any names, of course. Once a chimney flue lining starts to develop a problem, it is very hard to fix it. In order to take out the failing lining system and introduce a new lining system, which is practically the only solution, the unit will be out of commission for around 3 months. And of course, when a power station of many megawatts, maybe 600 or 800 megawatts, is out of commission for 3 months, this presents a huge problem and a huge cost, not only to the power station itself, but also to the electricity production system, which is relying on this capacity to be available.
As mentioned, really some important piece of information we have garnered from this discussion today. And my sincere thanks to you, Albert, for sharing your thoughts with us. With that, we come to the end of today's discussion. I sincerely believe our audience will take away with them some really good learning and work accordingly for a better and cleaner future. Team ET Energy World wishes all our audiences safety and the best of health. Stay safe, everyone. Thank you and have a great day.